Hello, everyone, and welcome to today's SANS webcast, Automating Open Source Security, a SANS review of WhiteSource, sponsored by WhiteSource. My name is Carol Auth of the SANS Institute, and I'll be moderating today's webcast. Today's featured speakers are Serge Borso, SANS Community Instructor and Analyst, and Rami Elron, Senior Director of Product Management at WhiteSource. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Serge.
Hello, everyone. My name is Serge Borso, and today we're going to be talking about WhiteSource's solution. Briefly about myself, I'm a SANS community instructor with over a decade of experience in the information or cybersecurity field. I operate an information security consulting company where we focus primarily on providing penetration testing services and security awareness training services. As a consultant working on the red team, I have the task of identifying flaws in PCI networks or mobile apps, web applications, and so on, and then producing a coherent report conveying what was found as part of that process. And part of this really revolves around understanding the business I'm working with, their products, their services, their culture, their expectations, and a large portion requires technical expertise to actually be successful and provide value without causing harm during a penetration test. And like most professionals, there is also a desire to continue and get better and innovate. And that's definitely what I'm all about. Doing a job well is one thing. Continually improving and honing skills is something else. And in my experience, what can help with this and essentially increasing efficiency is having the right tool for the job. And you don't always know what's out there until you look and learn about it. With that, I'm going to share my experiences over the last couple of months working with WhiteSource's solution. I'll talk about my initial thoughts on the tool, the areas I focused on, and basically what I learned and how to apply this knowledge. For today's agenda, at its core, what I want you to know is that WhiteSource is a security solution. It's a technology that integrates with the SDLC to enable security professionals to help development teams by providing information on the best components for a project and being able to identify and help prioritize vulnerabilities in the code, open source code specifically. So let's talk about how it works, and then I'll discuss its features and get into the new technology elements, which is called effective usage technology or effective usage analysis. Finally, I'll hand over the presentation to Rami for additional discussion on their solution. So what I'll be talking about is the background of the problem. What we're really dealing with here in the world of open source security and open source applications is a lot of components, a lot of vulnerabilities, and a lot of people having to spend time trying to figure this out for their organization, delve into remediations, working with other teams, working with continuous integration, continuous deployment pipeline, and getting your product to market in a timely fashion that's ultimately going to be secure to an extent when you release it. It's challenging. The reason why, and it's not just going to be web applications, of course, but the reason why we have the OWASP top 10 and injection is still number 1 on that list is because it's hard to do it. It's hard to write a robust, secure application that's going to be able to satisfy the needs of all your users and then continually maintain and update that, release new features, squish all the bugs, or remediate your vulnerabilities in a timely fashion. It's challenging to do this. So what WhiteSource tries to do, and I think they do a pretty good job based on my experience using the tool, is help us with automation of finding these vulnerabilities in open source components, and then kind of bridging the gap between not just the development team working on writing the code, but also the security professionals within your organization to help remediate those flaws and prioritize what's most important for the security of a given application. So kind of how it works here. The WhiteSource solution can be integrated with package managers, continuous integration servers, and build tools throughout a system of plugins, agents, and services. So integrating WhiteSource with my project when I went ahead and actually started doing my analysis of this tool, it was pretty straightforward. I logged into my account via the WhiteSource website. I accessed my API key, and then utilizing the Maven plugin, it basically parsed my POM file and created a project for me right within their dashboard. The plugin took the guesswork out of the integration process, so it wasn't too challenging to set this up. After it's configured, the plugin's job is to utilize the WhiteSource API, essentially, to send open source usage information to WhiteSource. In turn, I was able to see relevant information in the WhiteSource dashboard. Now, from there, WhiteSource's technology performed a hash calculation, essentially creates a digital signature for all the components of my project and compared the unique signatures with the signatures in its own database. And this is how I was able to detect the open source components in the project. So to be clear about that, basically it parses out, sees what components I have in a given project, and it checks a hash, makes a unique signature based on the different components that it finds, and then basically checks that hash against what it knows about. And if it knows that a given library or a given component of code has a vulnerability, then the tool's obviously in a pretty good position to say, hey, there's a known vulnerability to this because it's already been publicly identified. So that's essentially how it works. When I run my build, though, WhiteSource automatically populates the dashboard with real-time report that I'll show you here in just a moment. This shows all the open source components detected, as well as issues associated with those components. In terms of issues, I'm essentially talking about vulnerabilities. And I do want to touch on false positives briefly. There really shouldn't be any false positives with this component of the tool because of the hashing. Because of the hash calculation, there's a high degree of certainty that what's been identified by the tool is actually the component in question, and the rest of the work is based on publicly available information about the open source components. So the project inventory basically consists of a multitude of libraries that WhiteSource breaks down into their basic components. So we're talking about kind of looking at this screenshot right here, version, a language or type, description, associated products that may contain this component within my project or project inventory, SHA-1 hash, and additional features here, which is what we're looking at, like I said in this slide. It's the inventory report conveying all the libraries that comprise a given project. So it's a quick little view of kind of what we've included in our project. When the WhiteSource solution determines that one component has a vulnerability, it is this inventory detection mechanism that helps to easily identify other portions of our code or product base affected by the flaw. So this quick detection and identification provides security personnel with the means to ascertain the breadth of a given vulnerable component. So if I want to know where else a vulnerable component is being used at in my, across my organization, I can simply run this report once my project is integrated. So vulnerability detection and remediation. So this technology detects code with vulnerabilities and provides remediation information utilizing its database of known vulnerable components. We can see the results of this feature in the primary dashboard of the homepage, which we've already looked at here. What we can also leverage, or actually we'll see that here in a second, but we can also leverage these vulnerabilities to serve as kind of a filtering option to create reports and provide the basis for criteria to build policies using a policy feature, which I'll talk about in just a moment. This feature, this vulnerability detection feature, is important because it automates the discovery of problematic software components and can reduce the time it takes for security folks to become aware of the situation. Ultimately, I see this as potentially, increasing efficiency. Really, the faster I can be made aware of a flaw in my product base, the quicker I can get out of that situation and deal with it. So what we're looking at the bottom part of this slide right here is a detailed drill down into a specific vulnerability that was identified in my test project. The link to the CVE details is there as well, which is useful because if I need to get a more detailed read kind of on the actual CVE and the details of that vulnerability to remediate it, I just have it right there with a quick link. Once I got this far with using the tool, I had a pretty good understanding of what was kind of happening in the background. What I mean by that is at this point I've integrated it. I have a test product and a test project in there. The tool has parsed out all of the components I'm using, performed hash calculations. I have to do is just log into the dashboard and check it out to see what is found in terms of vulnerable components. And it's real time, when I run a build as to if I have some issues with the code, I get to see that immediately. And WhiteSource also provides suggested remediation steps, which I would expect, any mature tool that identifies security vulnerabilities also typically will tell you how to go about fixing it. That's nice though, it's built in. The suggested fixes typically involve updating affected software when possible. There's other methods to deal with vulnerabilities, so you can replace the affected code or change the components, but it's all kind of built right into the tool for us. So it takes some of the guesswork out of that. License compliance, what we're looking at here is a nice graph of the distribution of licenses within a given project that I've integrated into WhiteSource. So depending on your situation, you may have license restrictions, which could dictate the types of licensing that are appropriate for your components or your project or your business or your applications, really. Conversely, a common situation when dealing with open source software is a lack of any license being associated with a given library. So you'll be able to see what, if any, licenses in our code is associated, or what licenses are associated with the code base after we run an integration plugin and import the project. The WhiteSource solution detects the open source libraries in the project and subsequently assigns an open source license associated with that. So in-house or commercial components will appear as unknown or otherwise an unspecified license, which is what we're looking at here. You can kind of see at the top, we got the GPL. A lot of this is going to be Apache 2.0. There's also, some requires review at the bottom and a gray unspecified license. That's what those are referring to. For our own proprietary libraries, we can mark those as in-house by setting a rule based on a library name or some other unique indicator within the dashboard. Default behavior is the WhiteSource solutions identify all the open source licenses, and you can easily see that displayed here when you're not going to be in compliance as well. Policy enforcement, I just briefly touched on this just a moment ago, but the tool also has a policy component. So what we can do with this is we can create a policy based on attributes such as license type or vulnerability severity. So for example, we could set up a policy to fail a build if components have a high CVSS score. Not that most folks would ever do something like that, but the policy component does lend itself to the situation and capability. Also, in this slide, you can see that the tracker type option, we have integration with Jira and work items as well, which can be convenient depending on if your business is having to use those. Really, the point of this policy is to reduce the number of new components we have to manually review. So if we are only comfortable with using components based on certain license or vulnerability severity, we can leverage this feature to automate the process of allowing components to be used. It's really the sweet spot for this. There's also a browser plugin, just an FYI on this, a selection tool that WhiteSource provides. It's for Chrome right now, Chrome only, as far as I'm aware. So as developers browse like a Maven repository website, for example, the plugin tries to identify the components that we're looking at, and right within our browser, it'll break it down and say this is acceptable to use or not, based on the policy that we have created within the website or the web application dashboard. So what I mean by whether it's acceptable to use or not is based on how well is it maintained, the quality, quality, is it maintained well, is it contributed to, as well as the license type, is this license okay with us and our business, and the risk. So if we have too many vulnerabilities with a given component, right within our browser, as we're looking for that component, we can easily see that this is not going to be acceptable to use in our given situation. Next thing I want to talk about here is alerting. And what we're looking at here is the top alerts. This is the dashboard view. So WhiteSource will alert us when a new version of a library is made public, good to know, or when bugs are identified or a component has maybe multiple licenses associated with it. As with the other WhiteSource dashboards, the alerts overview does a great job of indicating the key elements of what caused the alert, and it provides the options to once again drill down into the details, or we can also choose to ignore the alert. There may be many times when we're well aware of the situation, we don't really care about it at this point in time, and we may need to go back and look at it at a future point in time. So we can ignore it, kind of declutter our interface, but still have that information available to us to reference back to. So what I mean by that is once you ignore some of these selected alerts right here, there's, of course, a way to go back and just check out the ones you previously ignored, for example. With that, what we also want to look at here and understand is that we can see the occurrences and the creation date and description and the type. We have all the applicable information, if you will, to really delve into why this is alerts, where is this component being used at, how many times is it occurring, so on and so forth. So it's pretty straightforward. It's useful from that perspective. And the alerting comes in the form of security alerts, like when a vulnerability is identified with the component we're using, or quality alerts, like when bugs in a component are detected, and policy alerts, as we discussed a moment before. We also get alerts when a new version of components is made available as well. So reporting, nice graph right here, or a nice page. It's pretty clearly laid out. I kind of like how that's done personally. This the reporting output. That's what we're looking at right here. The reporting output. We can generate reports using a dashboard, and we have a bit over a dozen options for reports. I'm just going to focus on one right now, and what that is the risk report, which is what we're looking at right here. It shows the overall risk score per organization or per product. So I use this to quantify the security of a given application or business unit and track code quality and how code quality and developer emphasis on security has improved security posture over time. What I mean by that is metrics, okay? We have to have some feature or some type of metrics to track and assist a business in understanding and evaluating its risk posture and determining where additional resources may be required to get a grip on a project that may have an inordinate amount of high vulnerabilities, for example. And this report helps me delve into that, and I can obviously share this with decision makers or with the business or with folks on the development team, as the case may be. So what I like about this is it's kind of like just one spot. You go to this, you check to see what the risk is with this application or with this code base or the component, wherever the case may be, in this case, the product. And you can just get kind of a nice sense of what the attack surface may be. And then below that, the last part of this slide right here, you can see the security, the vulnerability, the library, and once again, all the drill down options into exactly what you want to focus in on for remediation efforts. The big thing here that's changed with WhiteSource, for those of you who may be familiar with it, maybe more familiar with it than I am, is something called effective usage technology. And a big piece of this is going to be kind of the shift from first gen to second gen to this new technology. And I want to briefly cover this before I let Rami take over and share his knowledge. But a big piece of this product review was actually to get in front of the new technology, effective usage analysis. To understand this latest technology, I'm just, like I said, briefly talk about the original software composition analysis. What happened there was back in the day, over a decade ago, what we had for software composition analysis was essentially we tried to match code snippets to find references to open source components for an application. And then based on that, we might alerts of, if there's some vulnerabilities. It was slow. It wasn't really accurate. It's a lot of false positives. Trying to match on a code snippet wasn't ideal. Second generation software composition analysis came into the picture about 7 years ago or so and featured a lot of significant improvements, real-time feedback, full SDLC integration, fast scanning, accurate results in the context of like matching on an open source package being used, like per the hashing that we see now. There's a caveat though. When we use an open source component, this second generation technology assumes we've used the entire referenced open source code base or package. This method of identifying reference code can produce a whole list of vulnerabilities associated with the component, even when our code is not technically affected by it. So just like first gen SCA solutions were prone to false positives, this second generation solution is also not able to effectively or granularly identify which components are being executed. So while the second gen solution does a great job of identifying open source components, it doesn't typically have the capacity or insight into where or how a given component is being used and to what extent. So with that, WhiteSource's technology kind of tried to shift this, okay, and it generates some new technology to understand the way a user consumes open source components within an application, then map that back to the usage or the actual vulnerabilities identified with what's being used in the code base. So what happens, basically the technology identifies all the vulnerable functionalities, and then provides insights about whether the application is actually making the calls to the impacted code. So you have a library, you have an application, a library, or some component you're using. There's known vulnerabilities to that library, but is your code actually using the vulnerable function? That is what this is getting to the bottom of. This makes the vulnerability an effective vulnerability if you're actually using that vulnerable component and leveraging the vulnerable function of that code base. So it's pretty interesting. Security teams are able to provide the required evidence, and we can address these in real time or much quicker, or ignore it if we don't have a true finding. So the goal is no longer to match 100% on a given reference to a package, but rather identify which functions in a given library are actually being used by an application. Hence, effective usage analysis. And that was really what I was going for with this first gen, second gen, and third gen. So I'll skip over here to this vulnerability impact analysis. And what we're going here, talking about here basically, and I'll try to make this brief so I can pass over to Rami, like I said. So up until now, basically our conversation is concerned, nothing in the WhiteSource solution so far has conducted any code scanning at this point until we're talking about this new technology. There's a hashing function we talked about before, but that wasn't really a code scan. With effective usage technology component, there is a code scanning feature being incorporated. And we can enable this feature of effective usage technology via like a file system agent configuration file. So in order for the effective usage analysis technology to understand what components of code are actually being used, it has to scan the code base, which, if the wheels in your head are turning, it kind of is logical. I can't determine what components you're using without scanning to see what components you actually have. So performing this analysis can be a little bit slow, but the way that this is a little more efficient than other solutions I've seen is, other attempts at this. Effective usage technology overcomes, kind of slowness by leveraging the base technology we already have originally with this solution to perform a more robust scan on previously identified vulnerable components. So we don't scan everything necessarily. It's just more of what's already been identified as vulnerable. Then from there, we can delve in and just scan that code. So once we configure it, the effective usage analysis output's prominent. We can see it right here in the screenshot. The green that we're looking at means there's no effective references to vulnerable code. The yellow means some vulnerabilities in reference code identified, and the red means effective references from code can be mapped back to the identified vulnerabilities reported for a component. And gray, WhiteSource identified that the latest analysis of the library may be outdated. So we got a few different boxes or shields here that we can check out. So when we look at this effective usage analysis output from various perspectives, we can check it out from our organization or a product or a project and select the appropriate dashboard to view. Most of the time, I think teams will view the output on a product level to address effective vulnerabilities based on a product's criticality. What I want you to also know here is that this effective usage analysis can clearly depict where references to vulnerable code reside in a given library. And to be clear, if there's no vulnerability, then there's no attack surface, which means there is not a known path to application exploitation, at least at this level. The last thing I want to talk about here is the trace analysis components, which is also part of the effective usage technology. The trace analysis associated with the red shield provides us with a quick path to discovering the affected component. So it's kind of like another drill down where we found that top left here in the screenshot. You'll see you got the red shield up there. From there, we'll drill down to the bottom right where we actually see a trace view of exactly what we want to focus in on for remediation efforts, or for at least additional information about the details of the vulnerability and where it resides within our code. So logging is kind of an essential part of the debugging, and this trace view basically depicts the output of the effective usage technology, provides a log or reference point to what components affected down to the line of reference code. So this granular information also includes, dependency paths, the research in order to address the vulnerability, and ultimately this is going to, guide us to issues while providing some more pertinent information. So security folks alike now have the detailed information to delve into the finding and gain a deeper understanding of the root of the vulnerability, and as it may exist in other components or other parts of the business as well. All right, I think I've taken up enough time already. I'm going to go ahead and think about passing this over to Rami.
Well, thank you. Hello, everyone. Let me start by saying that for years, software developers have been facing an increasing challenge to deal with what seems to be an ever growing number of reported security vulnerabilities. Indeed, the sheer number of security vulnerabilities could possibly compel some to question their ability to address reported vulnerabilities in a manner that is effective, let alone efficient. The purpose of my presentation is to expand on some of the hallmark facets concerning effective usage analysis. So without further ado, let's dive into the first slide. As the slide notes, only some of the reported security vulnerabilities in open source libraries are referenced by the developer's code. Why is such a notion important? Let me explain. In an attempt to combat security vulnerabilities and doing so without compromising on agility, organizations have arguably been considering approaches to prioritize vulnerability handling. They were contemplating which ones constitute a real risk and which ones should be addressed first. That said, in lack of any means to detect how their projects are impacted by reported vulnerabilities, organizations, and perhaps to be more precise here, development and security teams in particular, have been struggling to establish the appropriate attention and perhaps I would say prioritization that was warranted for reported vulnerabilities. And some might also add that attaining such a goal has proven to be a daunting task. That said, it does not necessarily have to be that way. And in order to assess why, let's move to the next slide. As the slide build-up progresses, I would like to briefly address the important, even critical aspect of prioritization. Prioritization can become a truly viable proposition once one can establish which reported open source security vulnerabilities are actually effective and which ones are non-effective. Now, a reported security vulnerability in an open source component is deemed effective if its code is referenced either directly or indirectly by the software's project proprietary code. Since effective vulnerabilities are found to be referenced from proprietary code, that would mean that they could become prime candidates for prioritization. And perhaps alternatively put, an ability to detect effective vulnerabilities should enable organizations to not just effectively, but perhaps efficiently even prioritize remediation efforts. I would even add to that the higher the ratio between effective and non-effective vulnerabilities is, the higher the potential realized value is likely to be. As WhiteSource research revealed, the commonly observed ratio in software projects between non-effective, which on this slide are colored in green, and effective vulnerabilities that are colored in red, that observed ratio is pretty high. In fact, the ratio that is commonly evidenced in early deployment cases that we encountered was even more pronounced than the 7-30 ratio that is displayed on the slide. We have been evidencing 80-20, even 90-10 ratios. And again, these are no theoretical figures. Most importantly, though, these results, I believe, convey a sense of the value potential that underlies an ability to accurately detect vulnerabilities that are effective. And they would even suggest that such an ability could enable the development and security teams to efficiently prioritize the handling of vulnerabilities and the remediation efforts that are associated with such a process. This is essentially the raison d'etre, so to say, underpinning effective usage analysis. So let's please move to the next slide to discover more. I think that at this point, it becomes quite natural to ask, so what is effective usage analysis? It's a technology. It combines highly advanced technology with a powerful, which is also very friendly, user interface, a UI, user experience, whatever you prefer to call it. And it does so to produce an experience overall that enables development and security teams to efficiently deal with the security vulnerabilities, and importantly, while preserving agility. Not doing so while preserving agility would probably miss some of the key objectives associated with such a requirement in the first place. But effective usage analysis was really designed with advanced algorithms that result in highly accurate results and, as was also mentioned earlier, a low likelihood of false positives. The technology supports, in addition, swift analysis processing, and I would like to expand on that. It actually scales to support projects with hundreds and more of libraries. It typically completes analysis within mere minutes, frankly. And furthermore, the technology was designed to accommodate advanced language use cases. There are many examples I could perhaps share, but let me perhaps delay that if we have enough time at the end. Analysis results, importantly, this is an important point, analysis results are processed in a way so that there is an attempt to classify the vulnerabilities using what is officially called indicators or effectiveness indicators, and we perhaps more tentatively call them shields. These shields denote the analyzed effectiveness, and the UI implementation features a variety of such indicators and adds to that charts and reports that support assessments by users. It's actually pretty quick, such assessment. Now, when you look at the screen, you will see that the upper part, it's an excerpt that depicts two alerts that are marked with a green shield. And this denotes no found call traces leading from proprietary code to pertinent library vulnerabilities. The excerpt additionally depicts an alert that is marked with a red shield, and that denotes the discovery of a pertinent effective vulnerability. There is also an excerpt at the bottom of this slide, and this one portrays a trace that leads from the proprietary code, which is called the origin, to the target, or what we typically call the culprit for this use case, which is the vulnerable open source code. To sum this, I would say that effective usage analysis offers a truly powerful value proposition. And in order to fully understand how that comes into play, perhaps we should move to the next slide to reveal some of the key highlights. So the slide in front of you depicts what we consider to be the salient aspects of effective usage analysis value and its value proposition. Let me run by them. Perhaps I will pick on some of them in more detail. First, I think that we can tell that it enables considerable potential savings. That is due to several reasons. But first and foremost, thanks to minimized attention by developers towards non-prioritized vulnerabilities, and what culminates in higher work efficiency potential. Additionally, effective usage analysis produces highly accurate results. This could truly help organizations realize an accurate risk assessment, which is important because it's not just about assessing the risk, it's about getting as accurate as possible to determine what needs to be done. These are all actionable insights. And talking about the actionable insights, I think that another key item is the ability to facilitate such insights that concern vulnerabilities rather than merely capturing the vulnerability detail or minutiae, if you will. And this in turn promotes better remediation potential. Finally, I think that one could also argue that effective usage analysis fosters effective collaboration among different organizational teams, primarily development and security. How is this done? Well, there are many ways to answer that, but I think that the key approach here is by providing an objective metric, not just a subjective one, but a truly objective metric for prioritization, that by highlighting effective vulnerabilities that are warranting greater attention, it is possible to enable a win-win situation for both teams, security and development alike. In order to present the benefits that are associated with this feature, I would like to ask to move to our next slide. So there's actually a raft of helpful functions and capabilities that are incorporated in the implementation of effective usage analysis. In the next few slides, I'm going to highlight 6 of the most salient aspects. Let's please move to the first facet. So the first facet deals with the ability to receive in-depth information on security vulnerabilities. Effective usage analysis offers truly comprehensive vulnerability data, and this allows users to discover not just direct but indirect references as well from proprietary code to vulnerable open source code. The screen excerpt that you see in front of you displays the number of found references for vulnerabilities that are associated with such an alert. A reference indicates a found path. Let me perhaps I would like to actually expand a bit on this. A reference offers a way to understand what paths are found from the proprietary code to a vulnerability. A trace denotes a series of one or more calls that lead from proprietary code to a vulnerable open source component. And a vulnerability can have, in any given project, 0 or more references. Each of those references may feature one or more traces. This is actually pretty straightforward because the application of this is very consistent, and the ability to receive such information truly helps users establish what lies behind security vulnerabilities so that prioritization could actually take place. Let's please move on to the next slide. So here we see the ability to verify if a reported vulnerability constitutes a real risk. Effective usage analysis does not merely provide details on found traces. It additionally examines analysis results to subsequently classify alerts as being either effective or non-effective, as warranted. The display that you see in front of you, the excerpt, shows a green shield that is used to denote no found traces for a given alert. The text that is featured details a vulnerability-related data, and I will actually provide a bit more detail on that as we move to one of the subsequent slides. But suffice to say here that the pertinent library alert here has 6 reported security vulnerabilities that are of severity medium. Yet 0 of them, and this is captured in the parentheses, are effective. Since 0 reported vulnerabilities were found to be effective, the green shield was employed here to mark the library alert. Let's now move to the next slide. Another benefit is an ability to identify the location of calls that are made from proprietary code to the vulnerable open source code. Effective usage analysis in that way adds to the display detail information that you can see here encircled and clearly pointing at I would consider that to clearly point at the value that underlies such detail. We can see here the class, and we can see here the line number concerning the actual call that is made. And this enables users to understand not just what are the vulnerabilities associated with this trace, but also where they are referenced from proprietary code. Let's please move to the next slide. The following benefit concerns an ability to visualize open source usage through a depiction of call traces. Now, this is a term that you will in a moment get to see in its glory, so to say. Effective usage analysis is believed to truly help users not just get information, but visualize the way that open source components are being referenced. And this is done by displaying a full call trace. Mind you, not just a partial trace, but a full call trace. The featured excerpt that you see in front of you shows an example of a 3-element trace that leads from something that is called the application, and this is noted at the bottom of this trace, to the open source extension. And this display allows developers to examine the full call trace from proprietary code to the open source component. Now, I'm pretty tempted to expand on this and elaborate, but I will only say that there could be any number of traces. It is not limited by any means to a single trace. You could have 100 or more if so is relevant to the results of to the analysis results. And you will be able to scroll through them, just moving one by one and being able to evidence each of the traces and see how each of these options actually presents how calls can be made for vulnerabilities that are detected to be marked with a red shield, or in other words, effective, and to show how the calls are made from the proprietary code to the vulnerable open source code. Now let's please move to the next slide. Just before we actually complete this very short review of benefits of the effective usage analysis, one aspect that is interesting to note is not necessarily technical as the previous items or previous aspects were. In this case, I'm referring to the ability to support decision makers through graphics, through charts, and through an abundance of reports. The featured excerpt in front of you, this is an example for something that can allow users to compare between the reported vulnerabilities and effective vulnerabilities so that they could assess the relative percentage of different finding types. And again, you will be able to see that soon within the context of a given screen. So let's move to the last item on our 6-item listing here. And this, even though last, it definitely is not least, it's an ability to use and leverage a dedicated API for a programmatic access. An ability to extract the complete analysis result set using programmatic means is a godsend to many organizations because regardless of the value or or how attractive the UI is, many would actually ask for an ability to extract information and pass that to external tools that could be used both for automation and for any further analysis that is warranted. So this is indeed a key aspect of the support provided for effective usage analysis that enables both integration as well as promotes automation. So at this point, I think that we are ready to review how all of these presented aspects come into play as part of the system's UI. So let's move to the next slide to examine that in greater detail. So this slide really highlights two main areas that feature effective usage analysis related content, and they are highlighted as well. Area number 1 features shield and summary vulnerability detail for the listed library alerts. I would like to ask you to note that the list represents a subset of the alerts. There are more alerts as well, and also a dedicated listing of security-only alerts that can be viewed by selecting something that you can see in front of you. It's a security option button on the right side of the top alert table header. Now, as you can see the description, I'm looking at the area number 1. So the column that is highlighted there, the description, provides a graphical and a textual level of detail on each alert, using a shield on one hand to denote effectiveness and providing additional textual information to expand on such an indicator. We've already got acquainted with the red and green shields. The yellow shield denotes cases where typically effectiveness or non-effectiveness could not be fully established based on known vulnerability data. And as noted previously, there is also, I believe it was noted previously, there is also a gray shield that denotes a case where pertinent analysis results are possibly outdated. And that could be following changes to the library, for instance, a new vulnerability that was introduced, that was discovered and captured in the database. And it is recommended to run again analysis for projects that are marked with such a shield. Finally, let me add that there is also one last option, a no shield, or a blank shield, if you will, and it denotes cases where no analysis was run. So the particular element that does not have a shield was not subject to such analysis. Area number 2 features some graphs that portray important effective usage analysis statistics. If I were to start with a donut chart, it denotes the analysis coverage in the particular area of context. And I think that this is an important notion. Right now, we're looking at a screen, but it is important to accentuate the fact that you have information pertaining to a given context. Right now, we're looking at a product level, but there is also a project level. There are potentially multiple projects beneath a given product, and there could be multiple products under a given organization. So depending on the level you're at, depending on the context that you're looking at, you will see the depiction both on the left-hand part that is marked under area number 1 and area number 2 as well. All of this information matches the context, and this is incredibly important because it allows anyone to not just tell on a given context what are the presented results, but to compare different displays that concern the implementation and the usage of different components under different products or different projects. This is a very important aspect of the UI and actually represents and highlights some of its power. Now, in order to perhaps expand on that, you can see that the analysis coverage shows a percentage. It could be anything between 0 to 100, unsurprisingly. And when it is 100, that would simply mean that all of the elements that could be potentially subject to analysis are indeed so. There could be, of course, a case where you have yet to subject some of the projects to effective usage analysis, and you have maybe only be able thus far to do so for 50% of your environment. So as a result, the effective score that you will be able to see will not reflect the potential value, but the actual examination that was run by analysis. And that is also significant. That actually allows us to move upwards to see what is noted here as an overall score. And that overall score presents a number out of 10. To make it downright simple, I'll tell you this. If you haven't yet run any analysis whatsoever, and that goes for any environment where effective usage analysis is also non-applicable, you will get here a 10 out of 10. Basically, the score here corresponds with the reported vulnerability. So you could treat that as something of a percentage. However, if you are able to run analysis and you happen to find out that some of the results indicate green shields, those green shields in a relative sense will be removed from the 10, and then you will get a number out of 10 that represents your posture for all of your environment, regardless of whether or not it supports effective usage analysis or not. And this is because you may have a variety of projects, some of which are supported at the moment, and some are which are slated for support anytime soon. But the significance of this is that it enables you to get a view of your effective posture, regardless of the level of support that you right now have. That said, it is, after all, important to understand within the scope of analysis coverage what is the relative percentages, the relative percentage of each of the findings, whether it is effective or not. And for that purpose, you have the final graphic here, which is on the left part under area number 2. So here you may ask, why is that the analysis index is 3.3 or 3.3, and it looks the same for overall effective score. And this is pretty straightforward. This is because the analysis coverage is 100%. If it were not 100%, then you would see some discrepancy here. I must tell you that what actually struck us as highly interesting was the fact that all of these details proved to be immensely helpful for for customers when they ran their analysis based on the findings that effective usage analysis provided, because all of them really complemented each other. And once you get a bit used to the way that these graphics correspond with the findings, it becomes really second nature. Now, just to complete the review on this particular screen, look back under area number 1, and you will see that next to the shields, next to the colorful shields, there is also a textual description. If we pick, for instance, the item that is third from the bottom, and the reason I'm highlighting that option is because we are going to expand its view in the next slide. But before we do so, Jackson data bind. If you're looking at this item, you will notice that it has a red shield, and next to that you will see a textual description that notes high, and then a number 5, and a number and another number 1 within parentheses. The explanation for this, which was briefly noted or referenced earlier, is that for this particular library, there were found 5 reported vulnerabilities of severity high, out of which 1 was found by effective usage analysis to be effective. And in order to get a better glimpse at what lies underneath, let's please move to the next slide. So those who are familiar with WhiteSource would immediately tell that what we have here is an expansion of the original view that used to be provided when you clicked on details for any vulnerabilities. And this helps streamline the process of moving into effective usage analysis, usage, and the ability to leverage this as best as possible. I will not bore you with all the details here, even though I must confess most found them to be truly helpful in the sense of streamlining the process of determining what is the prioritization. But let me just highlight some of the quick tidbits that will help you better understand what we are looking at. So this view really complements the dashboard view that we previously saw with a detailed listing of analysis findings per each vulnerability. We see a hierarchical view. Area 1 features the shield, the shield detail. And note that there is a one-to-one relationship here between a vulnerability and the shield. This is in contrast with the earlier view when we examined the project level or a product level. The shield was calculated based on an aggregated and prioritized weighting, because you might ask, if I have multiple vulnerabilities under a given library, and let's say that one is red and the other one is green, what would be the result, the resulting shield for such a library? So we have also incorporated a prioritization level, a prioritization scheme based on which you could tell that there are different strengths here. And it's very straightforward and truly logical in a sense. Red is stronger than yellow. Yellow is stronger than green. As long as you keep in mind this pretty simple logic, you are able to tell what is the likely result of any aggregation that will be done on a higher level than the one you're looking at right now. But right now, it's a very straightforward depiction because there is a one-to-one relationship. So it's very simple. If you have found a path leading from proprietary code to vulnerable code, it will be red. And if you are looking at something where no such traces were found, it will be green. So given the fact that I noted earlier, this is a hierarchical view, you can probably already tell that by clicking on an element at the top of this screen, you will be able to present different details at the bottom part. And in this particular case, we have clicked on the third item from the top. We have here a red shielded item. And for that red shielded item, you can see at the bottom that there was one found reference to vulnerable entities. There could be many of them. This example is a pretty simple one, but there could be multiple results provided for that finding. However, in this particular case, you can see immediately what is the referenced entity ID, which is highlighted in red. And when you would click on such an item, on the right-hand side, in this particular case, since it's only a single finding, it was selected by default. But if you have multiple, you will click on the one that you prefer. And then on the right-hand side, you will see a full listing of caller traces. In this case, we have 2. And you can see that you move from one trace to the next one by scrolling. So you could simply look into that and figure out what is the path leading from the application to the open source vulnerable code. Now we have added, as you can tell, we have added means to quickly identify which row you are looking at. And in addition to that, you can see as was noted earlier, the class name and the line number, which is a boon for developers who are looking to find out where the call was made in order to either consider any changes to the code or even consider other approaches to remediate this situation. This is really becoming much more interesting as you dive into the information. Now, just as a very quick comment, the area that is highlighted as number 4 provides what we call a filter strip, and that goes to show you how we looked into the UI experience. Normally, it would be expected that customers would not just focus on the incident where there is a single jar that you want to examine its vulnerability findings. And some might say, I would like to see the same jar, but I would like to examine it in a different context. So normally, it would not be extremely peculiar to expect customers to step out of this screen and select a different context. We found out that this is a pretty straightforward process in terms of the workflow, and as a result, we incorporated the filter strip, which allows users to simply select the context, the product, and the project, and immediately, regardless of where they came from, see how the details change to reflect the new context. This was also a proven benefit for many customers that looked into the results and were interested in figuring out how they relate to others. So this is basically what I had planned here. This concludes my part. Thank you very much, and I'll return now to Serge.
Hey, thanks a lot, Rami. That was awesome. We're down to the last 4 minutes, I think, so maybe a good time to open up the discussion to the audience for questions.
Yeah, thank you both for that great presentation. I'll just jump in and get started. Our first question is, what does WhiteSource find for vulnerable libraries compared to OWASP depending checker?
Rami, did you want to take that one?
I'm sorry, I could not hear that.
It says, what does WhiteSource find for vulnerable libraries compared to OWASP dependency checker?
I think the question is regarding the maybe identification of vulnerabilities in the WhiteSource solution versus the OWASP dependency checker solution, kind of what the compare contrast is, maybe the value and what WhiteSource is doing, what it's going to find versus what OWASP's tool will find. I can't speak to that personally.
Does the question concern the nature of the findings with effective usage analysis? Because I would say that one of the special aspects of the process that WhiteSource is running enables not only to match the elements that are found in the customer's premise based on their identifiers, but allows us with analysis to figure out exactly whether or not a customer code is actually touching upon vulnerabilities. I think that serves as one of the key merits behind our particular implementation, because for the most part, one could argue that SCA tools were focusing on enabling a reduction of false positives by matching components based on their identifier, and that proved to be very helpful compared to traditional approaches that realized a certain sense of false positives, and that also added to the heft and to the overhead that many environments, I would say, suffered from and perhaps still suffer from. I think that a key benefit of having effective usage analysis, which is considered a differentiating factor, is an ability to reduce that count. And regardless of the numbers that were presented earlier, our experience so far showed that it is possible to reduce it quite significantly, to the point where where security and development need to work together, they appear to fight much less than they used to in the past, because there are now objective measures to direct what type of approach needs to be done in order to prioritize their process. I think that constitutes, together with other amenities such as policy handling and a comprehensive database, they together serve as a means to highlight the benefit of our particular implementation. I hope that addresses the question.
All right, thanks. We'll jump into one last one here before we go. In scenarios where we have applications that we do not have source code for, increasingly more common across all organizations, can effective usage technology be used for those applications to identify open source vulnerabilities? If not, can any other WhiteSource feature be used to review open source components or inventory applications?
I'll let Rami handle the second part of that, but I can say if you don't have the source code for it, and if it's open source, you should have access or the ability to at least find the source code, I would imagine in some cases. If you don't have the code, though, and you can't upload it, I don't think you'd be able to utilize this feature of the tool. But Rami can probably correct me if I'm wrong, or at least add some more information to that.
I would like to ask if you could repeat that second part, because I was unable to hear it probably.
Sure thing. Let's see here. I'm going to read the whole thing if that's okay. In scenarios where we have applications that we do not have source code for, increasingly more common across all organizations, can effective usage technology be used for those applications to identify open source vulnerabilities? If not, can any other WhiteSource feature be used to review open source components or inventory?
Well, we are not dependent on effective usage analysis to find out about vulnerabilities. The ability to use effective usage analysis helps to reduce the count of the resulting vulnerabilities to the point where they become a much more viable proposition for prioritization. But by no means is the existence of the source code or the ability to use effective usage analysis the only way to use WhiteSource for such vulnerabilities. It is definitely possible to use it without delving into such areas where effective usage analysis at that point becomes warranted.
All right, well, that's all the time we have for today. Thank you so much, Serge and Rami, for your great presentation, and to WhiteSource for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.
Thanks, everybody.
Thank you very much.